No problem.
Ma'am, you can start, I think so, ma'am.
Okay. I welcome Dr. K. Srinivasan Reddy, sir, Professor IIT Madras, and then I welcome all the participants from various organizations for the fifth day Atal online 6-day faculty program on innovative solutions for smart cities, enhancing mobility and urban sustainability. Today we have two sessions. First session will be handled by Srinivasan Reddy sir for in the title Empowering Smart Environment Through Renewable Energy Integration. And second session will be handled by Smart Traffic Management by Mamta Shri. And I would like to call Srividya, Assistant Professor at Takshashila University, to introduce our guest today. Srividya, I hand over the
Okay,
session
ma'am.
to you.
Thank you, ma'am. Thank you, ma'am. Myself, Srividya from School of Computational Engineering. I welcome Dr. K. Srinivasan Reddy, sir. He is a professor of mechanical engineering at IIT Madras and he obtained his PhD from IIT Delhi in energy studies in 1999. He then joined NIT Warangal and present in IIT Madras. And he is also an honorary professor at University of Exeter, UK. Professor Reddy is the member of National Academy of Engineering, World Society of Sustainable Energy Technologies, and International Society for Energy, Environment and Sustainability. He is specialized in renewable energy with special research interest on solar power, energy efficiency and environment. He has 10 patent applications and more than 350 publications with more than 10,500 citations and H index of 56. Professor has published books and book chapters in Springer on solar energy system. Professor Reddy is actively involved in the implementation of solar thermal technologies for power generation and process heat applications through design, development, demonstration, deployment approach. He has secured research funding for more than 30 research projects related to solar energy, energy and environment, and heat transfer area, supported by various Indian funding agencies such as DST, CSIR, MNRE, AICT, and various foreign funding agencies. In recognition for his research work, Dr. Reddy received awards such as WSSET Innovation Award, Sustainability Champion Award for the contribution towards research in sustainability domain. And also he received the Mid-Career Level Institute Research and Development Award, Sri J.C. Bose Patent Award, the Bhagyalakshmi and Krishna Iyengar Awards. He also won Career Award for Young Teachers from AICT in 2003. He acted as a member in Board of Governors IIT Tirupati. He is an expert committee member in various selection review committees and visitor nominee for IITs, NITs. As a part of human resource development activities, he supervised over 200 research students. Most of them are all well placed in and working in a prestigious organization. He organized several national and international workshops on advanced renewable energy technologies. His research area includes concentrated solar power and concentrated photovoltaic solar energy technologies for process heat and power generation, thermal energy storage, green hydrogen, renewable energy system integration for energy efficiency, and thermophysical property estimation of two-phase materials, thermal management of electric vehicle, and renewable energy integration, AI and ML in renewable energy. I am pleased to welcome Professor K. Srinivasa Reddy to handle this section on the topic Empowering Smart Environment through Renewable Energy Integration. I once again welcome you, sir. Sir, now the section is yours, sir. Sir, ma'am, am I audible?
Only. You are audible, Srividya.
Okay, ma'am. Okay, ma'am. Thank you, sir. Welcome you, sir.
Am I audible?
Yes, sir.
Now, so can you see my slide?
Yes, sir.
Can you see my slides?
Yes, sir. It's visible only.
Oh, thank you very much. So thank you very much. 1 minute. I will. Now, okay. You can see my slides, isn't it?
Yes, sir.
So, yeah, good evening. At the outset, I thank the organizers, mainly Dr. Lata, for inviting me to give a talk here in the FTP program um, on innovative solutions for smart cities, mainly enhancing mobility and urban sustainability. I am going to give a talk on mainly smart environments through renewable energy integration, how we can integrate renewable energy systems through a smart city concept. Before that, I would like to give how the smart technologies as well as the requirement for renewable energy integration in a sustainable environment. So if you look at we are facing several problems, and if you summarize these problems for next 50 years, we have energy, water, food, environment, poverty, terrorism and war, diseases, education, democracy and population. These are all problems which are facing across the world, but the topmost one is the energy. And if you try to address the problem of energy, we have to also address the problem of environment. Energy problem cannot be addressed in isolation. So therefore, energy and environment, they go together. So energy can solve most of these problems, and world's primary energy consumption is rapidly increasing based on the per capita energy consumption, improving in standard of living and industrialization, of course, the population growth. So any nation's standard of living primarily dependent on the energy consumption. So therefore, if you say if a particular country or an individual uh, consumes more energy, that means is more wealthy. So therefore, energy is one of the primary uh, indicator of standard of living. If you look at the energy sources, there are broadly two types of energy sources. One is celestial or income energy, which is this energy source comes from outer space to Earth's atmosphere. So these incoming energies includes solar and lunar energies, which we refer them as a non-depletable. Electromagnetic gravitational particle energy from stars, planets and the moon, and potential energy of meteorites entering into the Earth's atmosphere. But if you look at the quantity or quantum of energy that is reaching to the Earth's atmosphere, solar is the major fraction. I hope you can hear me, all of you.
Yes, sir.
Yes, okay, thank you. If any problem is there, please let me know, because I cannot see you, only I can see the slides. Okay.
Okay, sir. Okay. Sir.
The next one is the capital energy. Capital energy means which is already exists in and on Earth. That means the energy which is primarily fossil fuels and geothermal energy. So for that atomic energy in the form of chemical, but that's fossil fuels, and of course nuclear energy is also part of the energy which is capital energy. But if you look at the energy trends and the present energy consumption scenarios, the chemical for atomic energy in the form of chemical energy is their substantial energy. So therefore, now because of these capital energy, which is limited in resources, and also they give these resources will give significant impact on environment if you as we consume these resources. So therefore, there is a trade-off between energy and environment when you look at the capital energy forms. Energy reserves, the energy reserves broadly divided into four categories. Renewables, which again non-depletable sources like solar, wind, biomass and ocean. The other one is fossil fuels, coal, oil, gas, and then nuclear, which is in the form of both fission and fusion case. You have seen that the now nuclear in India also, the nuclear energy is gaining momentum, because in this budget also I think some substantial amount has been allocated for nuclear reactor design and development, mainly especially smaller ones. So now if you look at energy system hierarchy, we have energy sources, and this includes fossil fuel like oil, gas, and coal, and we have biomass, and then nuclear and renewable energies. These are transformed into a secondary energy carriers. Either it can be the electricity here or the liquid fuels, and ultimately they have to be used for as per the consumer choice, either for the mobility or the buildings. But in this process, in this conversion process, the greenhouse gases emission is an important factor here. So if you look at these energy services and sources through timeline, the industrialization started in the 1870s, and pre-industrialization, there was no commercial use of fossil fuels. So the coal started utilizing in 1870s. If you look at 100 years back, the 1770, there was no fossil fuels. It is primarily the animal power, and the input to that is hay, and again the supply of or the production of this fuel is primarily sunlight. So after industrialization, the commercial utilization of fossil fuels like coal, gasoline started every 100 years. Now, if you look at the pathways from fossil to the high calorific value fuel to low calorific value fuel to high calorific value. So if you look at coal, oil, gas, in these fuels, they are hydrocarbons, and the hydrogen content plays a substantial role. And if you increase the content of hydrogen, that means it's a better fuel. So instead of having one constituent in a fuel, better to go for complete hydrogen. So therefore, in future, by 2070, the Indian target is making it to net zero condition. So therefore, hydrogen is going to be one of the major fuel for the future. And if you produce this hydrogen by its renewable energy, then it's called green hydrogen. So therefore, in a smart environment, smart energy environment ecosystem, so the hydrogen is one of the key role. Hydrogen economy is a major player in future by future energy scenario. So we talk about Indian net zero scenario by 27. Now we are talking about 2047, which is a developed nation. So therefore, in this developed nation, sustainable energy solutions can play a major role to make energy sustainability. So if you look at the global energy potential with the present energy consumption is this, and this energy consumption is being met by various sources, energy sources like that. So, but if you look at these quantities which are placed adjacent to them, these each circle represents these quantities, but the demand is one here. But this, if you look at the bigger circle, which is solar, which is infinite, and it is inexhaustible, which can supply indefinitely to the world's energy source. So therefore, the renewable energy sources play a substantial role for the future energy scenario. So if you look at the energy demand and prosperity across the world, it is in terms of the night. This is the night picture taken by a satellite of the Earth. So you look at the Earth in the night, it looks like this. Wherever it's highly illuminated, you have energy demand and energy prosperity. And so there are some less illuminated places which are under energy poverty. You can see still several million people do not have access to the electricity, and still several million people primarily dependent on biomass for their primary energy consumption. If you look at in an international context how the global energy scene is changing, as you know that geopolitical instability, geopolitical unrest are playing a major role as far as the energy scene is concerned. You have a high energy prices, security of supply concern, then growing energy demand, climate change is another problem, geopolitics and resource nationalism, all are the major issues. And again, OPEC countries, the oil price volatility is another major issue. So these energy supply is primarily driven by goals and drivers, and the goals of energy is accessibility, availability, acceptability, and GDP drivers are GDP, energy demand, and energy supply. These are dynamically balanced with various other factors like demography, environment, institutions, pricing, and technologies. So therefore, the energy scene is primarily driven by its goals and drivers, and with various other factors. So generally, I propose a 6A criteria for the energy scenario. Accessibility, affordability, acceptability, adaptability, appropriateness, assurability are the major factors which govern the energy supply and energy demand. So if you look at energy reserves at the globe, coal, oil, gas, and nuclear are some. These are now predominantly supplies for the global energy demand. But of course, renewable is plays an important role, but it's gaining momentum slow by. So in future, we look at the energy renewable energy sector play a substantial role, and especially in a smart environment conditions. So the current oil reserve to production, oil is one of the fossil fuels. If you look at oil's current reserve to production ratio is somewhere as 40 years. After 40 years, we don't know what is the situation of the oil. If we consume at the same rate as, or if we produce at the same rate as present one, the oil can last, world oil can last another 40 years. So therefore, then after, what is that? And even if you consume indiscriminately, what is the effect of this on the environment? So then we need to go for new resources, new fossil fuel resources. That means we have to go deeper and deeper. And as you go deeper and deeper, you may find new resources, but the ultimately the cost of production will also increase, and ultimately at one stage it may not be viable. You cannot still drill to the center of the hole, center of the earth. So you cannot drill a hole to the center of the earth. So therefore, the technology plays an important role, because the present technologies can go maximum to 30 kilometers, but in a commercial way, it can go only 1.5 to maximum 3 kilometers deep. But if the technology is one aspect, and how you make it economically viable is another important thing. So sustainability is a major factor in any energy source to reach to the end of the end user or end of the chain. So we feel we deserve for a sophisticated luxury kind of environment where we get all the energy resources at our disposal. So, but the problem is the security of supply is a major concern. If you look at this car, and it's a luxury car which you can buy if you have money. You have it's a foreign technology, but it is driven by the fuel which is important fuel as far as the Indian condition concerned. And if there is any geopolitical disruption, like you see, if there is a war and all of a sudden if the supply from the Middle East stops, then what happens to this car? See, the supply plays a major role. So therefore, we should not land up into this situation. So in order to avoid this, we have to go for sustainability. So the earth is in bluish color, and when you look at from distance, and it is surrounded by the atmosphere, then we are consuming energy indiscriminately in the on the earth's surface. Because of that, the earth's atmosphere getting imbalanced. That means we are overloading the earth's atmosphere by the pollutants. So therefore, it is getting disturbed. You have seen climate change is a major challenge. Now, recently, you have seen the Californian fire, how it played a major role, and how the Indian weather conditioning is getting changed. The climate change is a very important. So any overloading is a dangerous phenomena. If you overload any system, it will get imbalanced. If you pollute too much, even our Delhi weather conditions, if you pollute too much, it will get disturbed. So therefore, energy resources sustainability is very important, and resources are limited here. and if there is no technology, it will extinct after some time. So therefore we have to go for technology here. This technology keeps these resources for the future. So therefore the sustainable development is an important criteria here. The sustainable development means the development that meets the needs of the present without compromising the ability of future generation to meet their own needs. That means you consume your share, but you keep the future generation share as it is. Otherwise, it will get imbalanced and the future generation will be in trouble. So therefore, as far as the energy sources are concerned, please try to consume your own share. So that is what we can attain. So therefore, the future generation says that there is only one earth we take care of, please. So therefore, energy sustainability can be attained by developing appropriate indigenous technologies. So therefore, it is your technology, your nation, your technology can cater your needs. So therefore, what to do? It's your money, your environment, your mission readiness. So therefore, you have to conserve your earth. Otherwise, it will have a substantial climatic impacts. So right things to do is to go for renewable energy technologies for making smart conditions. So there are several renewable energy technologies, and renewable energy technologies are mainly solar energy technologies. It's broadly classified into direct and indirect. All renewable energy technologies which are manifestation of sun's energy is called indirect renewable energy. Those includes water power, wind power, biofuel, mass, and ocean. Whereas there is a direct energy conversion from solar to either thermal heat or photovoltaics to get electricity, and this thermal route can be simpler one, and sometimes it's more efficient than the other one, and but the only thing is you need to make it more convertible into a high grade energy like work. So therefore the thermal conversion includes water heating, drying, food cooking, desalination, and greenhouse and power generation. So the sustainability is a very important aspect now. So therefore renewable energy technologies can untangle the um, triple bond, the development, energy, and environment. So this, you look at the sustainability is primarily governed by security of supplies, economic efficiency, that's the development, and environmental protection. We have to keep environment safe and clean. So this by the sustainability can be attained only the development of renewable energy or implementation of renewable energy technologies. There are several renewable energy technologies which you can look at, that sun's energy, wind's energy, biomass, and biofuels, diesel, biodiesel, bio-waste, and water, geothermal, and ocean. Ultimately, they need to be converted into a useful, high-quality energy by the generator. So, as a part of that, as mentioned earlier, that in a smart technology approach, we have developed several technologies in the solar system. So therefore, these are the few technologies I've listed out. Our approach is a 4D approach: design, development, demonstration, deployment approach. Through this approach, we have developed several technologies. And I'm not listing, I'll show you some of these. This is our lab and our group. And this group developed mainly the concentrating solar technologies plays an important role. As I mentioned, that the environment in a sustainable environment is a major challenge. So therefore, now the power generation, electrical energy generation is primarily supplied by the fossil fuels like coal. If you burn coal and produce power through a Rankine cycle, that is a conventional power plant. If you replace the fossil fuel by solar, then it is a concentrating solar power. There are 4 technologies have reached to the level of maturity to integrate them into the conventional or thermal power plants. So these technology plays an important role, which is these includes parabolic trough, parabolic dish, linear frontal reflector, and power tower. They have their own spaces in their technology domain, and they some of them are more efficient, some others are less efficient, but ultimately they are instruments in making more sustainable power. So the CSP technology, based on the temperature range, they are broadly classified into 100 to 400 and above 400. So the high temperature, medium temperature energy is produced by these respective technologies for power generation. So now we developed these technology at IIT Madras at different scales of operation. You see that our approach is a 4D approach: design, development, demonstration, deployment. And these technologies are, you can see at the demonstration scale, we have a parabolic dish which produces 640 degrees Celsius at 15 kilowatt thermal and 67%. And we have a photovoltaic system with the tracking. So it tracks the sun so that the overall efficiency is higher. And we have a desalination plant. We have parabolic trough collectors for process heating. Then we have concentrating photovoltaics for both electricity and water production. Then we have the instrumentation to measure that. So you look at that, it's a demonstration scale. If you look at with respect to these people, they are largely demonstration scale, and they can be taken to the field. And we have transferred technologies to some of the industries where the industries have taken to the field. And if you look at the technology wise, a parabolic dish collector is a concentrator which produces high temperature heat by reflecting the solar radiation onto this receiver, and then it produces high temperature heat. And the specifications are given, and every ray, because it needs to be tracked as the sun moves. The sun is moving from here to east to west, so as it moves east to west, you need to track this. So then this tracking system will, you can see here, tracking system keeps the solar collector in the direction of the sun, and the concentrated radiation comes here. So therefore, the parabolic dish collector is most efficient technology, and because we get higher temperature, and these are some of the, because the design of the cavity receiver is an important for not only production of heat but also fuels production like hydrogen and so on. And we have extensively done analysis for development of the cavity receiver for process heat and power generation applications. I have listed out the papers. Those who are really interested, they can go through these papers, and if you have any doubts, let me know. And when we go for large scale power generation, we need to go with the field. And the land area requirement is a major challenge nowadays in India, because land becomes expensive. So therefore, you cannot afford to have high land area for this. So therefore, in order to minimize the land area, we have done fields analysis and then operating conditions. We worked the entire country, like Kanyakumari to Ladakh. Kanyakumari latitude is about 8 degrees north, and to 35 degrees north we studied, and we made an atlas to come up with power generation across the India. Wherever the green points are there, they are viable, and where the blue points are conditionally viable. So then you red ones are they are not viable at all. So then these can be extended to another condition. This renewable energy integration in the pharmaceutical industry is another important idea. This dish we integrated to a pharmaceutical company. You see that the reactor, it produces heat, and this heat is supplied to a pharmaceutical industry here. Now another one is the parabolic trough, where it's a line focusing collector. You have parabola here and this one, and see the ray which fall on this will reflected on this line, and when you send the working fluid here, you'll get the hot fluid here, and you can track a single axis tracking and produce high temperature here. And if you look at that, the massive this is a setup where in our lab in IIT Madras, to mainly it's a mini power plant where to characterize the technology, especially the process heat and power generation technologies. So another, these are all we work with industry collaboration. The another dish technology, which is you see there's a one square dish, and another one is a circular dish. Both concentrate solar energy onto the focal point, and this is essentially used for air conditioning application, and this one is for process heat applications. So this is a 40 square meter dish. This is about 36 square meter dish. So you can see them here. And we also work a lot of characterization as an indoor experiment. So in indoor condition, we simulate the solar radiation, both optical size as well as two-phase side, flow side. And we set up our technologies in various locations. And this KG group is one of the groups in Coimbatore which set up our technology and then tested for a large-scale operation. So therefore, it is important to develop a linear frontal focal based PTC, process heat and power generation system. Here so you see this parabolic, because here when you do a technology demonstration, it has to be from various aspects, from optical to thermal to structural one. So as a designer of a technology or an inventor of a technology, it has to be a comprehensive analysis. We do optical analysis, thermal analysis, and the structural analysis. So if you look at the LFR collector here, this is again a development of a small solar system which reflect radiation onto this. So if you the concentrated light is here, which you can see the concentrated focus, this one. So now you have seen the receiver development. The receiver is a trapezoidal because we need to study both heat transfer and optical point of view. So here the heat losses from the receiver plays an important role. So therefore, you need to do extensive analysis as a heat exchanger design analysis for the higher heat collection. So based on this design, we have installed a power generation system in a school. This is the Pathashala campus in Vallipuram, Kanchipuram district, to produce power, hot water, cooking application, air conditioning, desalination, potable water production, as well as the air conditioning. So it produces multi products in terms of heat and electricity. There is energy storage which is stored inside so that it can operate in the night time as well. So now you have seen the temperature ranges are high, and this is the renewable energy integration for smart conditions here. Then we also developed a non-tracking elliptical 3D non-imaging concentrators. Mainly these are new innovative concentrators for low temperature applications, and they can be integrated. You see that these profiles are hyperbolic and then parabolic concentrated. The solar radiation is collected at the bottom and then used for a desalination applications. And the receiver is a cavity inverted cavity receiver, which plays a role or mainly used for collecting the concentrated radiation most effectively and with a minimum heat loss. So these are some of the configurations, and this can be effectively integrated with a desalination. Potable water is one of the important. You see that everywhere water is there, but you cannot use the water. Most of the water bodies are polluted. So therefore, how to convert the saline water or brackish water into potable water, and that can be done by a solar system, which is a sustainable solution for water production, because now you have seen RO, we are buying water in bottles. So therefore, this is a solution. So this solution can not only can be used not only for water production, that is potable water production, but also wastewater treatment. So suppose effluents are now just simply sent into the water bodies. So before sending into the water bodies, they have to be cleaned and treated. So therefore, water treatment is very expensive. So therefore, very expensive means cost intensive process. So therefore, utilizing the fossil fuels is another problem for the environment. So therefore, better to use for solar energy for wastewater. So we studied for various waters like saline water, brine, then brackish water, and so on. And this is the technology which our technology associates, which they collaborate with us, and they take it to the market. Some of these I have already shown this technology. And now another one is a textile effluent treatment. If you just now I mentioned that not only potable water treatment but also effluent water treatment is important. So therefore, we used our technology mainly textile effluent, where you textile, especially in Tirupur area, the textile effluents are rejected into this. So therefore, the treatment is a major challenge and it's a cost-intensive process. And this cost-intensive process making Indian textile become uncompetitive as compared to the Bangladeshi and other textiles. So we worked on this and come up with a solution for treatmenting of this. Another one is a mobility in a smart environment. Mobility is important now, as you know that smart mobility plays an important role, and if it is by green mobility like renewable energy integration or solar integration with mobile, this is a development and is compared with a conventional this one, and we found that this is you look at the emissions as well as the annual cost of these, so therefore it is more viable and less reduction is the emissions are much lower as compared to the conventional mobility application. So we have developed this technology, which is green technology, that means less greenhouse gases emissions, reduction in energy cost, and less noisy, and unlimited energy source solar. And we have done our students have done load and road conditions on in the campus here. And we can work on integrated collector solar system where it is a simple and which can give problem solution to the hot water system. And the flat plate solar PV panels, which are to be tracked with tracking system. We developed this tracking system which is more efficient and which delivers higher powers. So these are one of the, and the another important thing is for cogeneration, trigeneration, and it's mainly used. Hello? Any problem? Hello?
No, sir.
I,
No, sir, you can
if you
continue, sir.
if you have any questions, please. Some noise was there. So now this linear frontal reflectors, you know that in satellite we use solar cells. So these satellites are powered by solar energy. So similar solar cell, this is a triple junction solar cell, and which can also be used in terrestrial applications, but with the concentrators, and which gives a higher yield, higher efficiency. But of course, when it is used in a cogeneration, trigeneration mode, they are more attractive. These triple junction solar cells, indium gallium phosphorus, and indium gallium arsenide, and gallium on a gallium substrate. So this I have already explained. When we use this, mainly we integrated this desalination plant with a hyperbolic collector, parabolic collector, so that we can get a higher yield. So this I have already explained to you. This there's another technology which produces potable water by the simple technology, and it absorbs. It's a vertical type of steel which takes energy from both the sides and work effectively within a smaller space. This is what you know. Your program is on smart system, so there's a very smart because it's a it use a small area so that we can use area most effectively here. And the another technology is a multi-step technology where wastewater can be treated like a textile effluent, or even tannery effluents, or paper industry effluents, or domestic effluents can be cleaned in a most effective way. This one. So we also developed a solar drying system for human waste, converting human waste into fertilizer. Eventually, our objective is to based on desalination and drying technologies to develop a net zero discharge toilet, zero liquid, zero solid discharge toilet. So under Swachh Bharat, that means cleanliness is an important here. So therefore, we developed this converting human waste um, into into fertilizer. We can also use that. Again, it's coming here. This one is the same one, and the another important is when we go for smart solutions. The affordable net zero energy building sector in India is growing rapidly, and they are becoming energy intensive because most of them are air conditioned buildings. Then ultimately the energy consumption is increasing, and then indoor air quality is another challenge. So therefore it is important to come up with an affordable net zero energy building. So as a part of that, we developed a net zero energy building concept, which is covered with solar and then wind energy, and then we have solid waste approach. These are all integrated, and it's also they are very well illuminated or ventilated by changing the angle of the solar panels depending upon the position of the sun on in a any point of time, that is a time of the year. So therefore this is an approach, and it's affordable, and it's portable. So therefore you can take it wherever you want, and mainly you can install in an interior place or in remote places most. As just now mentioned, that we developed a net zero toilet, zero waste toilet. You can see that this is installed in our students hostel, Krishna hostel, and you can see that this it is hermetically sealed, there no smell. So this is a desalination unit, this is a drying unit. The liquid and solids are separated and sent to the respective this one, and then recycle. The liquid comes back as a flushing, and then top up, and solid will go down and then convert into fertilizer. And in order to drive the motors and other things, we have solar panels on that. These are all small ones. So this is a complete net zero energy solution. We have also come up with a renewable integration with biomass, mainly in rural areas where there is no power supply. So there's this we installed in a tribal village in West Bengal, close to Vishwabharati University, like Rabindranath Tagore's place. It is a full-fledged demonstration scale integration of renewable energy technologies for a smart environment. So here we have given power through biomass and solar plus battery storage. This is a battery storage you have, and this biogas is converted into electricity by a biogas generator, and which produces electricity. You can see here there are three sources: solar, and we also use electrolyzers to produce hydrogen. The hydrogen is supplied to the biogas to enrich this, and then you will get electricity. This village is about 60 huts, 60 houses in this. And a lot of research has gone in, a lot of research components went into this development of the technologies. We worked at IIT Madras, all these technologies, and it's also connected to the grid to make it a more reliable operation. So with this, I will come to a conclusion that the smart, where is that? Sorry, this one actually. So the one more important thing is how we can use renewable energy in a smart city concept. Here you see that whatever I have discussed, the technologies we can integrate into the smart city concept. Here you have seen a wide range of system integration. How do we couple with smart houses and mega solar park, and then so smart buildings here, and you can see environmental friendly design of buildings, then wind farms, battery storage here, then you have transportation sector, this EV sectors, solar panel installation, offshore wind, especially for Chennai, not Chennai, any coastal areas where you have offshore condition. Then so it's a comprehensive energy system integration, renewable energy system integration in a smart environment or smart built environment, smart city. So with this, I can conclude that the optimization of energy system for sustainable development can be achieved by analytical, numerical, and statistical tools. And some of this system design plays an important role for viable conditions, mainly process heat and power generation. Sustainable energy technologies can be achieved for DC concept, design, development, demonstration, deployment, and commercialization approach. So therefore, in a smart environment condition happened, renewable energy integration is a important tool for achieving sustainability. With this, I thank you. If you have any questions, see my friend is looking at your questions. So if you have any questions, you please ask so that I can answer on this person's behalf. Thank you very much. Hello? 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 Can you hear me?
Yes, sir.
What I completed my talk. So if you have any questions, please feel free to ask.
Participants, if you have queries, kindly you can post in the chat box or you can unmute yourself and you can ask.
So thank you, sir, for your presentation on renewable energy integration in smart cities.
Thank you very much. If there are no questions, I thank the audience.
I think there is no questions.
Okay, so no problem. Yeah, 1 minute. Yeah, thank you very much. If there are no questions, if you have any questions, please send. You have my email ID. You can send to my email also. No problem.
Okay, sir. Thank you, sir. Thank you for your nice presentation, sir. Thank you.
Thank you. All the best. And I wish the organizers to have a successful FDP, and I hope the participant will also get a good deal of materials from this FDP. I wish all the best to both the organizers as well as the participants. Thank you very much.
Thank you, sir.
All right. I'm signing off. I'm leaving the meeting.
Okay, sir.
Thank you. Bye.
Dear participants, we'll have the next session by 7:30. Stay all in the meeting. Srividya?
Yes, ma'am. Yes, ma'am.
Posted the
Yes,
feedback?
ma'am. Yeah, ma'am.
Mamta Shri ma'am will.
I have. I'm not
Feedback
able
has been
to.
posted in the chat box.
Okay. It's very
Yes, ma'am, you
difficult
can.
for me to.
Mm.
Yes, tell
Yes,
me,
ma'am. Yes.
Srividya.
No, the
It's
participants
taking time.
kindly you can fill the section feedback for this section. It has been posted by Prasanna Kumar sir. You can fill it, and next section we can start by 7:30. Yes, ma'am.
Yeah, some network issues always there. It's not possible for me to mute and unmute. Okay, we'll see in the next
Okay.
session.
Okay, ma'am. Divyalakshmi ma'am.
Hello.
Divyalakshmi ma'am.
Mamta,
Hello, Lata ma'am.